Hello, everyone. I welcome you all again to this live session by Great Learning. So, this is the first day of the week, and let's just be open with a new mindset so that we can learn as much as we can. And let's shrug off all of the Monday blues that we have with us, and let's just start off with this amazing learning session. So now, before I start off, just give me a quick confirmation if you can hear me and if you can see me properly. I need a quick confirmation in the chat. And while you're doing that, let me tell you about this platform called as Great Learning Academy. So what you see over here is Great Learning Academy, and this is an amazing initiative by Great Learning. So here you would see that we have all of these courses with respect to different domains. So we have data science, ML, AI, cloud computing, big data, and a lot more. Now, whenever you complete any course, you will get a course completion certificate, and you can go ahead and add that certificate onto your LinkedIn page or onto your resume. And that would be a huge value add to you guys. And the best part about all of these courses are these have been designed by industry experts. So you can be sure that your learning would be absolutely amazing. So now that I have given you guys the basic context of Great Learning Academy, we will start off with today's session. So let me just quickly head on to the chat and see what are you guys saying. And also I see that there's a watching of 56 and we've got only 6 likes as of now. Well, if all of you could hit the like button, that would be amazing. So let's just get to 50 likes in the next 2 minutes. That would be amazing. And also, if any of you haven't yet subscribed to our channel, also hit the subscribe button and also hit the bell icon. So whenever we are coming up with new live sessions or whenever we upload new videos, you'll be immediately notified if you subscribe to our channel and also hit the bell icon. And also our aim is to provide high quality education to everyone across the world. So if you like our live sessions, if you find our tutorials and live sessions to be insightful, spread the word of mouth about Great Learning to your friends, to your peers, and let them know that they can join this live session and also, upskill themselves regularly. And on that note, what we will do is start off with today's session. So today we are supposed to learn data analytics. Now, data analytics, well, this is a term which is used a lot. Now, I will start up by understanding what exactly is data. So folks, tell me, what do you understand by this term data? Right? You would have heard this a lot. Data is everywhere. Data is the oil. So what is it? Why is this important? And why is the field of analytics so important when it comes to data? Give me quick answers in the chat. Animesh is saying I've already completed 3 courses from your app. That is awesome, Animesh, and I hope you found all of those courses to be insightful. Dinesh is saying machine learning projects. Well, if you want more machine learning projects, you can just head to Great Learning Academy. I'm sure you'll find a lot of projects over there. Richard is saying one of the best channels on YouTube. Well, that makes us extremely glad. That makes us extremely happy. Thank you very much for saying that, Richard. So folks, I had a question to you. What do you mean by data? Right? Why is it so important in in today's generation, in today's day and age, and why are all of the companies, whether it's a tech company or a non-tech company, why are all of the startups and MNCs so obsessed with this term called as data? Kashyap Pandu is saying collection of facts. Yes, that is right. And hey Kashyap, it's good to see you again in the chat. Sandeep is asking what is the difference between data science and data analytics based on job role and functionalities. Well, we'll get there. Let's just first answer what is data, and let's understand the field of analytics. Then I'll also give you a context of DA versus DS job roles. Data is world. Somu Yadav, that's actually a very interesting answer. So if you look around you, what do you see? Whatever you see around you is data. right? So I'm right now holding a phone with me, and this phone is actually generating a lot of data right now. And let us say if I have anything else beside me that also is generating data every single second. Without data is nothing. Yes, Somu, that is right. Badulki is saying I'm from Nepal. Hey Badulki, it's good to have you on the stream. Right. So, as Kashyap has said, data is just collection of facts. Now, what do you mean by collection of facts? Well, whatever you have around you, as Somi Yadav was saying, that is essentially data. And data can be in the form of numbers, it can be in the form of text, it can be in the form of images or videos. So, this is just to give you guys the context. Data can be present in any format. And now let's understand how was data around 2 to 3 decades back and how is data currently. So data around 2 to 3 decades back was extremely small. So when I say data was extremely small, it was present in kilobytes or even less than that. And let's say in the early 1990s or the late 1990s, we would have something called as a floppy disk. So again, just let me know in the chat how many of you have heard of this storage device called as a floppy disk. So as far as I can remember, the maximum storage space of this floppy disk was 512 kilobytes. That's it, folks. Right? The maximum storage capacity of a floppy disk was only 512 kilobytes. And maybe 5 years before that, the storage would have been even less. So data back around 2 to 3 decades was very small, and that is why you did not have, no one thought of performing analysis on that data. And all of this data was mostly structured. So when I say structured, it would be present in the form of rows and columns. It would be tabular data. But something amazing happened in the last 20 years. What happened since the dawn of 2000 was social media exploded, internet exploded, and because of this you have data everywhere. So before the internet revolution, most of your data would have been present in tabular, or most of it would have been your log data. But after the internet revolution, after the social media revolution, your data is humongous and it is present in multiple formats. So when I say humongous, so just consider this: a floppy disk with a storage of 512 kilobytes. Now we have storage devices. So our laptops itself have a storage of maybe up to 50 GB or even more than that. You have a iPod, right? A simple iPod which is very small. iPod has storage up to 164 GB if I'm not wrong, or even 320 GB. Even our phones have capacity of lots of gigabytes. So we have a lot of data, and most of this data is unstructured. What is unstructured data? Simply put, whatever is not present in rows and columns. So your images, your videos, even your XML files, they can even be called as unstructured data. Now that we are sitting on top of all of this data, well, the best thing is we can find analytics from it. Whatever data it is, if you just look at the data and if you are able to find out information from this raw data, well, that could do a lot of things. So if your company has data, you can use that data to boost your company's revenue, or to increase your market segment, or even solve internal business problems. I'll just give you guys an example. So since we're doing all of these live sessions, and we're doing these live sessions on YouTube, so we also have an analytics team in Great Learning. So there's an analytics team in Great Learning who is looking at all of the data of the live sessions, and we want to understand what is it that you folks would want to watch, and what is it that that we need to focus on more, that so that we can reach more people. So there is analytics everywhere. Since there is data everywhere, that is why there is analytics everywhere. And since we have data everywhere, if you can just use any sort of analytical tools to find insights from it, that would be amazing. And this exactly is the field of data analytics or data science. right? So simply put, if you are able to find out insights from the raw data which is present around you, that is the field of data analytics. So that is clear for now. Now, after this, so someone had asked, what is the difference between the roles of a data analyst and a data scientist? So I'll give you a very simple example. What I'll do is I'll actually open up our studio over here, and maybe I'll open up a data set. Let's just call that data set as diamonds. So I have this diamonds data set. Now, from this data set, let's say if I would want to find out all those diamonds, so you have these different categories for color over here. If I would want to find out all those diamonds whose color is equal to J and whose cut is equal to good. So these are some sort of things which a data analyst would do. But if I have a different question, and now if I pose a question such as, if the color of the diamond is I, and if the cut of the diamond is ideal, what would be the price of the diamond? So questions like these are answered by data scientists. So a data analyst performs your basic exploratory data analysis. Your data scientist uses those raw insights and takes those raw insights and applies ML algorithms to either predict something or to classify something. So who had asked that question? I hope this answers. Floppy disks, yes sir. Very limited, yes. Fayaz is saying data is combination of text, images, video and audio, right? Ajay Patil is asking for data analyst which language of programming you need. Well, there are two primary languages in the field of analytics. One would be R. So this what you see, this is R Studio, which is used for R, and you can also use Python. So I have my Jupyter notebook over here as well. So you can use R and Python for most of your data analytics roles. And one more language which is equally important. This is not a programming language. This is a query language. And that would be SQL, structured query language. So one of either Python or R, and SQL would be, these would be your starter kit languages if you're applying for any of the data analyst roles. So now that we have understood about data, let's actually look at some of the problem statements which come under data analytics field. So here, forget the heading over here, it's stated ML, but let's just, since ML also comes under the field of analytics, let's just understand this example over here. So let's just say you are happily sitting at your home and you're streaming some movie on Netflix. Now you get a call or maybe a text message from your bank and telling you that you have purchased a diamond necklace from probably Australia, and the cost of that diamond necklace would be around let's say 10 lakh rupees. And now the problem is you have never been to Australia and you have never spent more than 10,000 rupees on your card ever. So this is a bit fishy. And this text message or whoever is calling you also asks you whether this transaction was actually done by you. So you know that this is a fraudulent transaction, but how does your bank know that this actually might be a fraudulent transaction? Well, the answer is analytics. What is happening over here is your bank actually has a track of all of your transactions. And there'd be some ML algorithms or analytics algorithms which would understand your pattern of spending. So that algorithm would know that normally you have never used your card to purchase anything outside of India and you have never spent more than 10,000 rupees for a single transaction with your card. So this sudden transaction of 10 lakh rupees, which has, which is also a luxury item and which you normally wouldn't do. And you are sent a text message or you get a call asking for the confirmation. So this is an example of machine learning or analytics. So this is just one example. Now, what we'll do is we'll also look at the data mining lifecycle or the entire data analytics lifecycle. So, whenever we are dealing with data, we'd have to understand that there's data everywhere. So, I guess initially someone had said that data is present everywhere around you. That is right. Now, when data is present everywhere around you, you would have to collect that data. So, this is the first stage of your entire data analytics lifecycle. Now, how do you collect your data? Well, you have a lot of tools. So if you're talking about big data, you have tools such as Flume and Scoop. So Flume and Scoop would help you to collect, humongous amounts of data. And this could also be coming at a rapid pace and also at a continuous pace. And you'd be collecting this data, and also you'd have to understand that this data might be present in multiple formats and also coming from multiple sources. So this data acquisition is also the place where you have to integrate the data. So integration of data is very important because let's say you have one file which is in CSV format, another file which is a document, another file which would be, let's say, a PDF, you have another image, and let's say you have a .mp4 file as well. But there is relevant information in each of these files, right? So the doc will give you one set of information, the PDF file will give you second set of information, the image might give you third set of information, and the video might give you fourth set of information. Now you would need collectively all of these documents or all of these data items. So what you do is you have to integrate the data. But how do you do that? Well, first you'd have to dump all of this in a central storage repository. So let's just call that central storage repository as a data warehouse. Now, once you store everything in a data warehouse, here you'd have to decide on the format of your data. Maybe you convert everything into a CSV file, or maybe you convert everything into images. So decide on one particular format, and that is where you integrate the data. So now after integrating the data, and once you have your final raw data with you, you'd have to do your data pre-processing. And since you only have raw data, this raw data has to be converted into tidy data. So what is tidy data? Well, let me actually tell you what is the problem with raw data. So when it comes to raw data, you will have missing values, you will have anomalies, you will have outliers. So all of these things have to be treated properly. And if you have to convert your untidy data into tidy data, you would need help of data pre-processing. So again, you'd be using languages such as R, Python, SQL to convert your untidy data into tidy data. And also remember that if you're working as a data analyst, this is your entire job role, data pre-processing. And also if you're working as a data scientist, even then around 30 to 40% of your work would be related over here. And understand why this is important, because if your data itself is incorrect, your final output would definitely be incorrect. So I'm repeating this again, right? Let this get into your head properly. If your raw data is incorrect, your final result would definitely be incorrect. And now let me make it even more clear. Now let's say if I make a hypothesis that I make a random statement. Let's say the random statement is, if I wear a blue shirt on a Monday, it will rain, right? So this is a statement, and if I take this statement as a fact and I do not verify this, so what is the statement? If I wear a blue shirt, so right now I'm wearing a blue shirt, so this would mean that it will rain today. Now I'm not verifying this is just a random statement which I have made, and well, since I have the freedom of speech, I can make any random statement. And now the problem is this is an incorrect statement, and that is why this data has to be verified. So this is what you're actually doing in data pre-processing. Data pre-processing, again, simply put, you are fact checking your data, or whatever untidy data you have, you're converting that untidy data into tidy data, right? So now once you convert your untidy data into tidy data, we have the next phase, which is ML. So in ML, this is where you apply all of your algorithms. So depending on the problem statement, you'd be applying a classification algorithm, a regression algorithm, or maybe a clustering algorithm. Then you'll get a result. Now, once you get a result, again, it's not necessary that whatever output you get, it has to be definitely correct. The problem is, again, you'd have to, as you have verified the data, similarly, you'd have to verify the answer as well, right? So as I made a statement that if I wear a blue shirt, it will rain. Now, since that was my initial raw data, let's say the output is, if I wear a blue shirt, I will win a lottery ticket of 1 lakh rupees, right? So this is the output which I've got. So since the data is wrong, the output which I've got is also wrong. Or it might be any other case. So maybe, the algorithm which I've built is incorrect. Or maybe the hyperparameters which I've given over here are not properly tuned. And that is why the final result which I've got is, if I wear a blue colored shirt, I will win lottery of 1 lakh rupees. And that obviously is an incorrect statement. So these are all of the evaluations which you have to do. Now, once you know that the final result which you get is correct, then you can go ahead and show or represent your knowledge. And how do you do that? Well, you have your beautiful graphs. So you have your BI tools such as Tableau, Power BI, and with the help of these, you can create beautiful dashboards, and you will present these dashboards to your clients or to to the decision makers of the company. So this is the entire data mining life cycle. Now let's understand each of these. So data acquisition, as I've told you, data can be present in multiple formats and is coming from multiple sources, right? So then you have the central storage repository. This central storage repository, let's call it a data warehouse. You'll combine all of these different data items. You'll store them over here and you'll decide on one particular data item or one particular data format. And by convention, it would probably be a CSV file or an Excel file. So you'll convert all of these data items into a CSV file or an Excel file. And over here, once you store it, so you have your final target data. Now, what is target data? So again, since data is coming from multiple sources, it's also necessary for you to understand that not every single data item which is present is important. Here, I have integrated every single data item, but my problem statement does not require me to deal with. So let's say if the final sheet over here has 150 columns and my problem statement would require me to deal with only, let's say, 100 of these columns. Or let me put it this way. So out of the 150 columns, only 100 columns out of these are relevant to my problem statement. So here, only those 100 factors combined would be your target data. So this is your phase of data acquisition. Once you get your target data, this is where you'll pre-process your data. So as I've told you, all of your checking of outliers, checking of missing values, and the basic EDA, which is exploratory data analysis. So EDA, you have again two subcategories. One is data manipulation and one is data visualization. Data manipulation, I've already given you guys an example, right? So data manipulation is simple, finding simple insights. So let's say, so here you have X, Y, and Z. So X is this is basically the length, width, and depth of these diamonds over here. So X is length of the diamond, Y is height of the diamond, or maybe the width of the diamond. Now, let's say if I want to extract all of the diamonds whose width is greater than 4. So that is an example of data manipulation. Now, what is data visualization? So let's say if I want to, if I would want to find out the distribution of the price of the diamonds, right? Or if I want to make a histogram for the price of the diamonds. So that is an example of data visualization. So let me show you how both of them can be done in our language. For data manipulation, I have this library called as deployer. and dplyr is the core library for data manipulation in R. Now what I'll do is, this is my problem statement. I'd want to extract all of the diamonds whose y value, so y is width, whose width is greater than 4. So what do? I write down the name of the data set, which is diamonds. Then I will give in the pipe operator. So this, what you see, is known as the pipe operator, and I will use the filter function. The filter function is a part of the dplyr package. So on top of this diamonds data frame, I'm using this filter function, and what is the condition over here? Y is greater than 4, and this I am, let's say, storing in a new object. Let's call it as diamond width 4. Now let me open this up, diamonds width 4, and so here, as you see, if you look at this particular column y, you would see that all the values are greater than 4, right? 4.07, 4.23, 4.35. You are able to see that all the values are greater than 4. Similarly, if I want all the values to be, let's say, greater than 6, I can do the same thing. So y is greater than 6. Let me store this in a new object. Let me call this diamonds width 6, view of diamonds width 6. So this time, if you look at this column, so here you would see that you have all of the values greater than 6. So the initial data frame which you had, you would see that there are approximately 54,000 diamonds. So out of the 54,000 diamonds in total, you have 22,000 diamonds, which is almost close to 45%. So 45% of the diamonds have their width to be greater than 6. Right? So these are the sort of things which you do in the data manipulation task. Now, as I've told you, let's visualize something. So to perform visualization, we have this library called as ggplot2, and I would want to understand the distribution of this price column. So what I'll do is I'll write down ggplot, which again is a function which is part of the ggplot2 library, which is very intuitive. So first I'll start off with the data layer, and what is the data which I'm working with? I am working with the diamonds data frame. So I will map the diamonds object onto the data layer. Then I will use AES, which is basically aesthetic. So what are aesthetics? Aesthetics are basically the metrics onto which you can map your columns. So onto the X aesthetic, what I'm doing is I'll actually map price over here. So I'm mapping the price column onto the X aesthetic or X axis. Once I do that, let me go ahead and make a histogram. So to make a histogram, I'll write down geom histogram and let me hit enter. So here, as you see, I have created this histogram which would tell me the distribution of prices of these diamonds. And here you can, so here on the, so this is the price, and here you have the count of these diamonds. So if I just look at these two bars, so probably there would be around, let's say, so let's just take this particular bar. So there would be around, let's call this around 14,000 maybe, or 13 to 14,000. There would be 13 to 14,000 diamonds whose price would be probably around $300 or less than $500, right? So you have in this entire data set which has 50,000 diamonds. Out of those 50,000 diamonds, you have around 15,000 diamonds or 13 or 12,000 diamonds whose price is around $500. And if you look at this, you have very few diamonds in this data set whose price is greater than $10,000. And if you look at this step over here, then probably you would have only around 5 or 6 diamonds, or even lesser than that, where the price of the diamond would be around close to $17,000 or $16,000. So these are all of the insights which you can get from these graphs over here. Now, if I would want to make this even more beautiful, since this is data visualization, well, visualization, if you can make it beautiful, well, just do it. So here, what I'm going to do is, let's say if I want to add a color to this, which is extremely simple. So inside geom histogram, I have this attribute called as fill, And let me give this a color. Let's call this pale green 4 probably. So here, as you see, I have given a color to this. So these are all the things which you can do. This is a fill color. And similarly, if I would want to give a boundary color, that is also something which I can do. So for boundary color, I have the call parameter. Let me just give this a normal green color. So call is equal to green. And here you would see that I have given a fill color as well as a boundary color over here. So these are just some examples of data manipulation and data visualization. So I'll go ahead and look at the chat again. So folks, I want this session to be very interesting, so keep coming up with your questions. Nishi is saying I used Power BI before, now my company got Tableau, so I use Tableau. Well, that's interesting to know, Nishi. David says greetings from Peru. Great to have you on the session, David, and I hope you're finding the session informative. Shashank is asking what skill set you need to have to get a job as a data analyst. Please tell me, it will really help me. Well, for data analysts, see, there are a few basic requirements. And one of those basic, when it comes to languages, either Python or R, and I'd actually recommend you to learn both of them, right? Because both of the languages are very similar. If you know one language, you can pick up the language in a very short span of time. So learn Python, learn R, and another language you definitely need to know for a data analyst role is SQL. Data scientist role, not so much of SQL, but a data analyst role, definitely you need to be good at SQL. And apart from this, it's also good if you have knowledge of BI tools. So it could be any of the BI tool, but currently in the market, Tableau is the best. So it's better if you learn Tableau instead of maybe other BI tools. So Tableau, Python or R, and SQL would be your starter kit. And apart from this, a bit of knowledge on statistics. Again, since it's a data analyst role, you wouldn't require heavy knowledge or heavy lifting of statistics. So basic knowledge of measures of central tendency, measures of deviation, and a few statistical concepts would be decent enough. And probably a knowledge of few of the algorithms. Again, not in depth, but decent knowledge of it would be more than enough. So once you're good with this, you can go ahead and start applying for the different roles over there. Shashank Tripathi is asking, is machine learning essential for data analyst role? Well, I'd say not really, because a data analyst, as I've told you, would mostly deal with the EDA stage. Right, so right now what we are doing is exploratory data analysis, and this is what mostly a data analyst would work on. Implementing of ML algorithms, tweaking of ML algorithms, that is something which a data scientist would do. So what you can do is maybe enter as a data analyst, and then you can probably switch to the role of a data scientist or an ML engineer. Ankit is asking, should we make notes for Python course? Well, if that helps you, why not? Well, people learn differently. So, so I'm someone who would probably watch videos to learn a concept and, not really read, because I find watching videos to be more intuitive, and it just, the learning is much more easier for me. And let's say if it's a coding session, what I do is I have my console open right over here, and whatever the instructor is teaching, I parallelly do it. So that is how I learn. And if for you, let's say if writing the codes down or writing the syntax down and practicing it on a piece of paper, if you think that helps you, well, go ahead and do that. Mickey Sharma is asking, BI means, so the full form of BI is business intelligence. Ankur Malik is saying, please teach us web scraping because data is extracted from there. So I had already taken a session on web scraping using Python, which was a long time ago. So you can just go to our YouTube channel after the live session and just type in web scraping using Python, and you'll learn how to do it. So I'll probably take one more question and I'll head back to our session over here. Ritika Sharma is asking, is NLP required much? Well, that's again an interesting question. Now, when you talk about NLP, that again is a very niche domain in the field of AI. And NLP is required where, let's say, there is a project related to chatbots or voice assistant or anything related to text or speech. So what is NLP? NLP is natural language processing. So it basically deals with wherever you are converting the natural language or human spoken language into machine understandable language. And most or the relevant domains which deal with NLP are the applications of chatbots and voice assistants. So let's say if you're looking, if you're looking for a job role where these are the job descriptions, then you have to be good at NLP definitely. And for NLP, you'd have to know about recurrent neural networks. So most of your chatbots and voice assistants are implemented through recurrent neural networks, and you need to have knowledge of deep learning frameworks such as Keras, TensorFlow, and PyTorch. Right. So now that I have answered this, we'll go back to our session. And again, I see that there's a watching of 101 and we've got only 77 likes. So folks, if all of you could hit the like button, that would, that would make me happy. So quickly hit the like button and let's reach 100 likes right now. And also, if you haven't hit subscribed, hit the subscribe button, also hit the bell icon. So if you are finding our sessions to be insightful, tell people about Great Learning, because we would want to reach out to more people about Great Learning Academy. So hit the subscribe button and also hit the bell icon. So we have covered both of these right now. Now let's see what else do we have. Next up we have ML. So in this stage, as I've told you, once we are done with EDA and once we have the proper data with us, we are supposed to apply intelligent algorithms. And now these are so let's actually understand what is ML. Let me give you an example. So I have this pen over here. Now, how do I know this is a pen? Well, as a kid, I would have been told by my parents or by my teacher that this is a pen, and I had a feedback in my brain. So my brain, it understood that this is a pen, and whenever I look at it, there'd be a tag in my mind, PEN, right? Similarly, let's say if it is a bottle over here, my parents or my kindergarten teachers would have told me that this is a bottle. And the not exactly a label, because as a kid you wouldn't know the label of this, but the word, it would resound in your mind. This is a bottle, this is a pen. So this is what is known as reinforcement, and this is how our brain learned. And this is the same concept in machine learning as well. So if you are supposed to teach a machine something, so if I'm supposed to teach a machine that this is a pen, what I'll do is I'll keep on feeding these images of a pen to the machine. And once it learns all of the features of this pen, then I'll give it new pen. Then I'll give it basically a new pen. So this is a blue colored pen. Maybe I'll give it a red colored pen or a black colored pen, and try to gauge if it has, if it has been properly trained or not. And under ML, we have certain subdomains. We have something called as unsupervised learning. We have supervised learning, and we also have reinforcement learning. And now, we will probably not, let's actually dive into each of these topics over here. So, depending on the problem statement, you'll be using each of these. And for today, let's only understand about supervised and unsupervised. So, just for now, understand that when it comes to ML, we are applying this on a raw data set. And when we are applying an ML algorithm, that would give us a result. And again, that result which you get might not be totally accurate. And this is where pattern evaluation comes. So in pattern evaluation, we would have to verify whatever result we've got is correct and actually usable. Now, once we know that the result which we've got is accurate enough, we can go ahead and represent the knowledge. And as I have already told you, we can use any of the dashboards or visualization tools to show the final result to our clients or to the decision makers. This is the entire data analytics lifecycle. Now that we are done with this, let's actually look at the categories of machine learning. So we also have something called as reinforcement learning, but then again, we'll leave that out. So for now, let's only focus on supervised and unsupervised learning. Let's start with the first one. And now, in supervised learning, well, whatever machine learning algorithm it is, you basically have to feed data to it. Now, when you're feeding data to a supervised learning algorithm, your data basically has input variables and there'd be probably one output variable. Your input variable is denoted as X and your output variable is denoted by Y. And you're trying to understand what is the relationship between Y and X. So here, your X is also known as the independent variable and Y is also known as the dependent variable. Since the output of Y is dependent on X, right? Since the output of Y is dependent on X, that is why it is called the dependent variable and X is known as the independent variable. And what we are trying to understand is, so how does Y change with X? And again, in supervised learning, we have two types of algorithms which you probably have heard of. So we have regression and classification. Now let's start off with classification. What exactly is a classification algorithm? We have a very interesting example over here. So before we understand this example, let me give you a context of classification algorithm. Now, let's say if you have data with you and it has a lot of data items and you have to classify something. Now, let's say if that example or the data set is about all of those folks who have taken loan from a bank, and I'd want to understand how many of them would be able to pay back that loan and how many of those folks would be defaulting on that loan. So here I have two categories. One is this person will pay back, the another is this person will default. So this, what I'm doing over here is classification, and for this I would have a lot of different factors. So that could be the factor of, let's say, this person's salary, this person's age, this person's if this person has taken any loan in the past, what is his credit history, all of these different factors are taken into account. And all of those factors are the independent variables. And on the basis of those independent variables, I'm trying to understand whether this person will be able to pay back the loan or not. Now, we have a similar example over here. So here, let's say there's a survey done on certain patients, and the problem statement is you're basically trying to find out if someone smokes, what is the probability of him or her having cancer? Or it's basically yes or no, right? Let's say if there's a person who smokes, I would want to categorize him as having cancer or not. So here, your dependent variable is categorical in nature. It's yes or no, right? So here your independent variable is, again, it's yes or no, whether this person smokes or not. And on the basis of this, I am trying to categorize this person as yes, he has cancer, or no, he does not have cancer. Now let me also give you another example of classification. So there's this algorithm called as decision tree, which is one of the most widely used classification algorithms. So the problem statement is, let's say, if you want to watch the movie Avengers, or let's frame it in a way, yes or no. Should I watch the movie Avengers? And the problem statement is this: should I watch the movie Avengers? Now, the final decision of yes or no would be taken on a set of decisions. So let's say the first decision is, do you like Robert Downey Jr.? So if the answer is yes, then you'll go ahead down the tree. If the answer is no, well, you will not watch the movie. So if the answer is yes to if you like Robert Downey Jr., probably there might be another question. Do you like Marvel movies? If the answer is yes, again, you'll probably come down and there'll be another question. So let's say, do you like Scarlett Johansson? And again, if the answer is yes to that, then your final answer would be yes, I will watch the movie Avengers. And if the answer is no to any of the decision-making statements earlier, then you'll drop off from the tree. So this again is an example of a classification algorithm. Now we'll head on to regression. And especially we'll focus on something called as linear regression. So what do you understand by linear? So linear is a straight line, isn't it? Y is equal to mx plus c. So here you have this formula, y is equal to f of x. So here x is linear, right? It's not x square, it's not x cube, it's only x. And when we have y is equal to x, or let's say y is equal to 3x plus 5, or y is equal to 7x minus 2, all of these represent a line. And a line is basically the underlying concept of linear regression. And here, when it comes to linear regression, your dependent variable should be a continuous numerical, and your independent variable should be it probably should be a continuous numerical as well. And we've got a very simple example over here. So on the x-axis we have CGPAs of all the students, and on the y-axis we have the GRE scores of all the students. Consider this case study. Let's say if there's been a survey done in a college, and I'd want to understand, is there a relationship between the CGPA of the student and the GRE score of the student? So here, what I'll do is, let's say if there are 600 odd students in final year of engineering. So what I'll do is I'll go to all of these 600 students. I'll ask them what is their CGPA. I'll also ask them what is their GRE score. And now what I'll do is I'll make up two columns. One column would be CGPA, another column would be GRE score, and I'll list out both of these. And here, what I'll do is I'll start off by making a plot. So on the x-axis, I'll map CGPA, on the y-axis, I'll map GRE score, and what I see is the relationship between these two is linear. So this tells me that if the CGPA of the student is high, then the student might get a high GRE score. And if the CGPA of the student is low, then probably the GRE score of the student would also be low. So this is a linear relationship. But what this graph does not tell me is, let's say if I pose a question such as, if the CGPA of the student is 8.3, what is the GRE score of the student, or probably what would be the GRE score of the student? And this is where linear regression comes in. So here y is equal to function of x. So let's say here our y is the GRE score of the student, and x is the CGPA of the student. And when I input the value of CGPA of the student, I need to immediately get the GRE score of the student. Right? Y is a function of x. And here the GRE score is a function of the CGPA of the student. So let's say if, and this is where, so let's say this is the best fit line of linear regression, and if the CGPA is 8.3, and let's say 8.3 is somewhere over here, I'll draw a vertical line like this, and I'll draw a horizontal line like this. So this would mean that if the CGPA of the student is 8.3, then the GRE score of the student would probably somewhere be around 313 to 314. So this is something which you can get from linear regression. Now again, let me head back to the chat and see if there are any more questions over here. John Rafael is asking, is there a mobile app? Yes, we do have a mobile app for Great Learning. So I believe someone from my team would be putting up, would be putting up the link for Great Learning Academy over here. Anusuya Tarafdar is asking, can we call it as probability? So with respect to what is this exactly? Could you give me more context? SK Logic is asking, what is the difference between supervised and unsupervised learning? Well, we are just about to cover that. So till now we have only covered supervised learning, and under supervised we have covered classification and regression. It will just give me a couple of minutes. I'll just take up some of your questions, and we will also cover unsupervised learning over here. Kashyap Pandu is asking, what if a person has both highest graduation, which is PhD, and skills in DS? Well, that would be amazing. So normally, all of the all of your ML engineers and all of the people who work in the field of computer science, they at least have a master's, if not a PhD. And it's actually good if you have master's degree, because some of the mathematical concepts which are required, they would only probably be taught in your master's or a PhD. So now let's say right now, if you only have a bachelor's degree, your mathematical understanding of machine learning concepts would be limited. But if you probably do a master's degree or a PhD, your concepts of statistics and how you'll approach to build these ML algorithms would probably become better. And there are actually two ways. So let's say if you do not want to invest on a master's or a PhD, you can also develop those skills by yourself. And that is why you actually have courses by Great Learning as well, right? So now Great Learning offers all of these certificate courses with university tie-ups, where you can cover these courses in a span of probably 11 months, or so between 6 months to 11 months, where you learn all of the mathematical foundations and statistical foundations, so that you're good to go for most of the interviews anywhere. Right, so if you have the time and if you think you can put in the effort for a master's degree or a PhD degree, well, go for it. But you have other options as well, and that would totally be your choice of what you'd want to do. Dark Knight is saying, tell about logistic regression. Well, we do not have enough time for today, so probably we'll cover logistic regression in some other session. Fayaz is asking, can we use Excel as a data analytics tool? Yes, absolutely, that can be used. Right. So what we'll do is, since we have only 8 minutes left, I'll quickly also cover unsupervised learning. So we have covered supervised learning till now. Now let's head to the next subcategory in ML, which is unsupervised learning. Now, when it came to supervised learning, you had data which had labels with it, right? So you had input variables, you had output variables, and your output variables had labels. But when it comes to unsupervised learning, your data will not have labels. It is just your data, your raw input. And now I'll give you guys this example. So let's say if you have all of these data items. So I've got, let's say, all of these cars and bicycles with me, or images of these cars and bicycles with me, and I'd go ahead and build an unsupervised learning algorithm on top of this. Now, this unsupervised learning algorithm is actually a clustering algorithm, and this would provide me two clusters. So here you would see that the first cluster only has cars and the second cluster only has bicycles. Now, even though there are no class labels associated here, this algorithm is able to divide this data into two clusters. How is that happening? Well, this is happening because this algorithm understands the underlying structure of the data, and it looks at the similarities of the data items. How similar are the data items? And here there are two concepts. One is known as intra-cluster similarity and the other is known as inter-cluster dissimilarity. So if you look at all of the items which are present in this particular group, you would see that you have three cars over here, and all of these three cars are very similar to each other. So this is what is known as intra-cluster similarity. So again, in this cluster we have three bicycles, and again all of these three bicycles are very similar to each other, and this again is known as intra-cluster similarity. But when I compare cluster 1 with cluster 2, you would see that I have cars over here and I have bicycles over here. So if I compare cars with bicycles, they are very dissimilar. And this is known as inter-cluster dissimilarity. And what a clustering algorithm does is, it increases the intra-cluster similarity and it also increases the inter-cluster dissimilarity. So in other words, the items within a group should be as similar to each other as possible, and the items in two different groups should be as dissimilar to each other as possible. And all of this is possible because of this unsupervised learning algorithm. So this unsupervised learning algorithm understands the data points which are there and understand it looks at the similarity, and depending on the similarity it divides them. And how does it understand if two data items are similar? Well, you have distance metrics over here, but that again would be a bit technical. So just understand that if you have to find similarity of data points, you have different distance metrics. And when it comes to k-means clustering, so let's say if the algorithm over here used as k-means clustering, then the distance metric used over here would probably be your Gaussian distance. So your Gaussian distance you would have learnt in your high school or primary school, which is basically under root of x1 minus x2 whole square plus y1 minus y2 whole square. So that is how an algorithm calculates the distance between different data points, and if the distance between two data points is small, that be considered as similar, and if the distance between two data points is large, that be considered as dissimilar. And this is unsupervised learning. So I hope now you guys understand the difference between supervised and unsupervised learning. So also folks, if you again haven't yet liked our video, let me quickly remind you, please hit the like button. So that would help us a lot in reaching out to more audience. If you like more people would be notified about this live session. And also if you haven't yet subscribed to our channel, hit the subscribe button and also hit the bell icon. So folks, let me just take up some more questions for today, and we can end the session. Rahul Sharma is asking, for data analyst, Python, SQL, statistics and Power BI is sufficient. Well, that needs to be enough for most of the data analyst positions, and probably you can add Excel skills over there as well, because a data analyst would probably be working with macros in Excel. So it's probably either or SQL or Excel, but it's also good enough skill to because Excel skills always come in handy. You can also add Excel to the skill set. Mickey Sharma is asking, would you help by providing some programs over every topics of Python, soft and hard copy? So if you want the data sets or the code files of of most of the tutorials which are present on YouTube, I'd recommend you folks to again go to Great Learning Academy. So all the courses which are there on Great Learning Academy, you will get the PDFs used in the course, the data sets used in the course, and also the code files used in the course. Right? Since these are live sessions, right, you'll probably have a difficult task of getting getting the data set and the code file and the PPT from us, but once you enroll to GLA, everything would be available to you. Right folks, so this would be it from my side for